Hello everyone, this is DSA Zindabad. Today we are going to solve the 20th question of virtual DSA sheet, and the question is merge sorted array. Now let's look at the problem statement. You are given two integer arrays nums1 and nums2 sorted in non-decreasing order and two integers m and n representing the number of elements in nums1 and nums2 respectively. Merge nums1 and nums2 into a single array sorted in non-decreasing order. The final sorted array should not be returned by the function, but instead be stored inside the array nums1. To accommodate this, nums1 has a length of m plus n, where the first m elements denote the elements that should be merged, and the last n elements are set to 0 and should be ignored. Nums2 has a length of n. Now, the question says we have two arrays, nums1 and nums2. Nums1 is of length m plus n, and nums2 has a length of n, right? Now let's take the example to understand the problem statement in a better way. Nums1, 1, 2, 3, 0, 0, 0. We can see over there, last n elements are set to 0 and should be ignored. These are n elements and these are m, right? And nums2 is 2, 5, 6, right? And n here is 3, m value is also 3, right? So from this, what we need to do, the goal is to convert both of them array into a single array such that the array will be a sorted one. What do I mean by this? Like we need to, the answer would be 1, 2, 3. From there, 1, 2, 2, 3, 5, 6. This will be our answer from these two arrays, right? Because like the arrays we are merging are 1, 2, 3, 2, 5, 6. The result of the merge is 1, 2, 2, 3, 5, 6 with the underlying elements coming from nums1. And we need to make sure, like after sorting, the goal is to make nums1, right? Here it's like said that the final sorted array should not be returned by the function, but instead be stored inside the array nums1, right? That's why nums1 has a length of m plus n, right? And the last n elements represent 0, and after merging, this will be our nums1 array, right? So our goal is to merge both of the array into a single array such that the array will be a sorted one. And it would be like obviously nums1 as said in the question, right? Now let's look at the second example also. From there, like we have nums1 as 1 and nums2 as 0, since there is no length. So the ultimate result will be 1, right? And this one is the third example. Nums1 is empty and nums2 contains one element. So after merging, this will be 1, right? The 0 is only there to ensure the merge result can fit in nums1, right? Because as we said, like nums1 is of size m plus n and nums2 is of n, right? So now let's jump into the approach and try to figure out how we can solve this question, right? Approach. So first of all, let's talk about the brute force approach, right? This is our example, nums1, which is 1, 2, 3, 0, 0, 0, right? And nums2 is 2, 5, 6, right? These are the two arrays. So brute force approach says like, let's take another array 1, right? Which is of length m plus n. Its length will be exactly same as that of the nums1, right? So what we'll be doing, we'll just put two pointers over there, I and let's j in nums2, and we'll start comparing both and I and j. Then after like we need to figure out if I is less than j, like if I is greater than j, then j needs to be there, right? Obviously, right? So initially I and j, from there we can directly see one is smaller than that of the two, right? One. Then after this, it will be pointing to 2. Again, we'll compare both and I and j. This says we have 2, right? So again, we'll increment our pointer to this. So now again, we can directly see j is lesser than I, right? So we'll put 2 over there. Now we'll increment our j pointer from I and j, 3 and 5, which is smaller, 3 obviously, right? We'll increment our pointer. From there, we can directly see like which element is greater, right? 0 here represents the like the n element should be present over there, right? So from there we can directly see like this can be considered as like int max, right? So what we need to do, we need to compare whose value is smaller. Like 5 is obviously less than that of the int max, right? 0 represents int max. We need to consider this, right? So we'll directly store 5 over there. Again, increment our pointer. Again, the same thing, right? So 6 will be there. And at the end of this, since we need to store this array 1 in nums1, we will directly run a for loop over the entire array and try to traverse, and will directly copy this result into the nums1, right? Nums1 will be equal to array 1, right? So as you can see, like this approach has no issue in case of time complexity, right? The time complexity ultimately would be big O of n. But when you talk about the space complexity, its space complexity will be big O of n, because we need to take another array so that like we can combine both of the arrays, right? So now let's try to reduce this time complexity to big O of 1, right? So now let's jump into the optimized approach and try to figure out how we can solve this question. This one is the optimized approach. So let's take this example. Nums1 is nums1 is 1, 2, 3, 0, 0, 0, right? And nums2 is 2, 5, 6. So now let's try to observe the pattern. Like instead of storing, like instead of comparing the smaller element, let's try to be like, let's try to compare the larger element. Like, what do I mean? We'll just like need to replace these all of these zeros with this element, right? This is the question, right? So that like instead of taking another array, we'll directly store all of these elements into the in place of these zeros, right? So what we'll be doing, we'll start traversing in a backward direction. Like we'll start filling first of all this zero. Like what we'll do, we'll first of all fill this zero, then this zero, then this zero, right? So we'll traverse in a backward direction. So now what we'll be doing, we'll directly fill this with this, right? So now initially, uh, let me just remove all of this. This is zero, right? Initially, our like so to traverse the array, what we need pointers, right? This is our last one, right? So we'll have two more pointers also. Like since we need to be make sure ourselves like we need to compare the larger elements this time, larger elements. That's why we need to traverse from the backward direction, right? So one of the pointer will be pointing to this element, and the another pointer will be pointing to this. So let's say this is our I and this is our J, right? These, so we need to take three pointers. Last one is to like fill all of the zeros, I and J, right? These three pointers. So what we need to do, we need to compare I and J. If I is greater than J, then we need to fill that zero with the help of I. If J is greater than I, then we need to fill it with the J. We need to keep this thing in our mind. Like from there, we can directly see 6 is greater than 3. So this 0 will be filled by this 6, right? So after filling this, what we need to do, we need to increment our pointer also, which is last. So our last pointer will be pointing to this, right? Since we filled this 6, right? We use this 6, so we also need to increment our this pointer. So again, we'll compare both the values. As we can directly see, 5 is greater than 3. So this 5 will be stored there. So again, we'll increment our last pointer. And now this time, our j pointer will be pointing to 2. From there, we can directly see 3 is greater than that of the 2, right? So this 3 will be filled over there. right? These are our elements which are filled, right? 3, 5, 6. And over there we have 3. So after this, we'll increment our pointer to this. So as you can see, like both of the values are equal. So it will not affect our result, like whether we are storing this with the help of either this two or either this two, right? So let's say we are storing this with the help of this pointer, right? So as we can see, like j goes out of bound over there. J is less than 0 this time. So this two will be there, right? And our I pointer will be there as it is, right? So as you can see, like we already use 2, 5, 6 in place of like these zeros. So after this, our array will look something like this, like 3, 5, 6, and 2. And these green element represent, these are already present in nums1, right? So we change the array something to this, and this is our sorted array, right? Right? There might be some condition like when like this value is 3, 3 or something, what I can say, like this value is 1 or else or something. So we need to fill all the leftover in nums1, right? Uh, this thing will be clear to all of you guys as soon as I start coding this approach, right? I hope this approach is clear to all of you guys, and the dragon to like how we are traversing over the both the arrays without using any extra space, right? So this approach will take big of n time complexity, and the space complexity will be big of 1 since we are not using any extra space over there, right? So now let's try to code this thing up, right? So here we are. This one is the last pointer, which will be pointing to m plus n minus 1, right? So now we need to traverse in the backward direction. So m should be greater than 0 and n should be greater than 0, right? After this, we need to check if nums of 1, m minus 1, the last index of the nums 1 is greater than that of the nums 2, nums 2's last index, right? So at this point of time, what we need to do? We need to nums 1, put it over there at the last index. Nums 1 of last will be equal to nums 1 of m minus 1, right? Also, we need to decrement our m. Else, what we need to do? We need to nums 1 of last will be equal to nums 2 of n minus 1, right? So there n minus minus. And also we need to decrement our last pointer also, because we need to fill all the zeros, right? So at this point of time, like we also need to follow, we need to fill the nums 1 with the remaining elements of nums 2. This one is the edge case, right? Nums 2, if there are leftover elements, right? So we need to check while n is greater than 0, right? Then nums 1 of last will be equal to nums 2 of n minus 1 directly, right? And again, we need to decrement n pointer also last pointer. This one is the edge case, right? This one, right? So I guess this will work. Now let's run this code. Yeah, this runs perfectly fine. Now let's try to submit this code. Oh, sorry. We forgot to add last minus minus, right? Again, try to submit this code. Yeah, this is accepted now. So now let's look into the time complexity and space complexity for this code. As you can see, like we'll just traversing over the entire array. So our time complexity would be big of n. And as we are not using any extra space, so our space complexity would be big of n, no extra space. No extra space, right? Thank you so much for viewing the video till the end. Please like, share, subscribe, and comment if you have any doubt. Thank you so much.